offered it, asked for a price first for one leg and then for the other leg. And for the leg back, they were prepared to pay $17.19. Another group was offered insurance for the entire trip for both flights, and they were prepared to pay almost as much, $13.90. And while the final group was offered insurance covering the entire thing, both flights and the whole time on the ground for terrorism insurance, they were prepared to pay $7.44. The more they were offered, the more they got out of what they bought, the less they were prepared to pay. And again, this is a bias a little bit like conjunction bias, in that the later cases cover the earlier cases, and yet, because the earlier cases discuss a more vivid scenario, a more perhaps representative scenario of what you imagine terrorism might involve, the people ascribe it more weight and are prepared to pay more for it. So that's maybe slightly less scary version of scope neglect, where you can see that people are valuing the larger thing less than the smaller thing because people don't have a proper sense of scale. So here's the really scary version. They were told that a certain amount of money, I don't know, 100,000 shekels, this experiment was done in Israel, was needed to save, in the first case, 8 children with little pictures, 8 pictured children with a terrible disease, and with this money they could save them all. The second group was told the same amount of money was needed to save just a single child. Now, to me, saving 8 children is a great bargain compared to saving 1 child. It's potentially worth 8 times as much. But when asked about it separately, the subjects were prepared to pay half as much. Now that's not just missing the bullseye, that's missing it by a factor of 16. They're 16 out compared to where they should be on the relative valuations of the life of 8 children over 1 child. James?
I would imagine there'd be a presentation issue, because you can put the 1 child and say, this is Jeremy, and his mum died when he was 5, and you can sort of spin a story.
But that's the one paper. I don't think. No, I mean the presentation was designed to be balanced. I mean they gave the same amount of information about the 1 child as they did about each of the 8 children in the other experiments. But also, like I say, bear in mind that there are lots of experiments that measure scope and sensitivity. It's really well established. There's another one where you ask people. You talk about birds that might that go into oil wells, and their wings. Once they get the oil on the wings, they drown. And they're told we want to put nets over these oil wells to protect the birds from the oil reservoirs rather. And you tell one group you're going to have 2,000 birds, one group 20,000 birds are affected a year, the other group 200,000 birds are affected a year. And you increase the scope of the problem by a factor of 100. People are barely moved. They give almost exactly the same result. They treat it just the same way. They have this example in the mind of this one bird, its wings, covered in oil, desperately trying to get out. And that's what controls how much they give. The scope of the problem plays almost no role in the amount they're prepared to give. I think I've got this lot out. Yes. Bias assimilation. This is about the way that we read evidence, very much the way we want to suit what we already believe. This is Francis Bacon, one of the founders of the scientific method. And here's what he had to say about it in the 17th century. The human understanding, when it has once adopted an opinion, draws all things else to support and agree with it. And though there be a greater number and weight of instances to be found on the other side, yet these it either neglects and despises, or else, by some distinction, sets aside and rejects, in order that by this great and pernicious predetermination, the authority of its former conclusion may remain inviolate. And this is exactly what Lord Ross and Lepper demonstrated in a 1979 experiment. They collected 24 people who were strongly pro the death penalty and 24 who were strongly anti, and showed them these 2 studies. So this first study compares states which have changed the law, who may change the law on the death penalty, and measured the change in the murder rate. That study supported the deterrent effect of the death penalty. Whereas this study compared neighbouring states and looked at murder rates. That research opposed the deterrent effect of the death penalty. And so, of course, the pro-death penalty people thought that this first study was a very well done study that had proper controls and was good science, while the second one had all sorts of flaws in the way the states were chosen, the way the study was carried out, the statistics that were done. And the more they saw the studies, the more they felt the first one was the good study. And they left the having seen both studies, they were more convinced than they started of their pro-death penalty position. Of course, the anti-death penalty people had exactly the opposite effect. They thought this was the study that was properly conducted. This was the one that they could identify all sorts of problems with. And they came away feeling that more convinced than ever before that the death penalty did not have a deterrent effect. Actually, that isn't quite how they do it, because they only showed 12 subjects on each side, these two studies, while the other 12 subjects on each side were shown these two studies. Since the studies are entirely fictitious, and of course they do debrief people and tell them the studies are fictitious when they finish. Since studies are entirely fictitious, they could just say, just swapped around the conclusions, and all of a sudden the pro-death penalty people thought that this was the one that really was the one you should rely on, this was the way to study these things, whereas this one had all sorts of terrible flaws they could identify, and the anti-death penalty people saw it exactly the other way around. Again, they left more convinced than they started of what the deterrent effect death penalty was.
Is that the same as confirmation bias?
It's related to confirmation bias. It's a subfield of confirmation bias called bias assimilation, but it is strongly related to confirmation bias.
You know, whatever the results say, while I can poke holes in both, I mean, is that all the information they were given in each case?
No, they were given, first of all, they were given these summaries, and that was measured. And then they were given entire fictitious scientific papers to go through. So they were given, and the more information they had, the more they were able to poke holes in the study, and the more they became convinced that the study that favoured their existing opinion was the good one.
You may be coming to this later, but would a computer have none of these biases, or some of them?
A computer that implemented this particular bias, you can show it does make sense. It does make sense to think that a study that backs up your conclusions is more likely to be a good study than a study that doesn't back up your conclusions. But if you integrate the evidence correctly, you can't suffer from this problem. If you correctly weight the conclusion.
I mean, a computer running what program?
Yes.
If it's a computer running a human brain emulation, it probably would have this bias.
Yes, but I mean, you're asking if you have the correct mathematical structure of reason.
I mean, you're talking about having like a computer system that's smarter than humans, right? That doesn't have any biases.
No.
So there are such systems?
No. But something that I'm about to go. I'll be later in the talk. I'll be discussing the mathematics of rationality. If the way that you integrate evidence is consistent with that mathematics, then you won't suffer from this bias.
I mean, to paraphrase this, people believe what they want to believe.
People largely believe what they want to believe. It's even worse than that, as I'll come to in a second. Go ahead, Tom.
Actually, there's something to say about that on research on perception. Some research seems to show that this kind of bias actually plays a role in improving perception, for instance, in sums. So you tend to reinforce a hypothesis rather than look for disconfirmation. So it may be interesting to keep that in mind about different subsystems of the brain, maybe not needing the same kind of impartiality.
Well, I mean, certainly our perception is hypothesis-driven, but I mean, machine vision and this sort of thing does tend to use Bayesian techniques, which aren't vulnerable to these problems. So it's a kind of sign, even our perceptual systems are not Bayesian, and you can probably demonstrate similar biases, but I'm afraid I don't know anything about that, so I couldn't really be sure. So that's that one. Right, yes, so that's all the biases. That's all the ones I've got time to cover here. The Wikipedia category on cognitive bias has over 150 articles in it. I mean, I'll just do a very brief run through of some of the biases I haven't covered. Confirmation bias, which you mentioned, is the sort of broader bias of that we look for evidence that backs up what we believe rather than evidence that contradicts it. The hindsight effect, where if we're told about the outcome of something, we tend to believe we would have seen it coming in advance. They did an experiment where they asked people to guess what the outcome would have been in a military conflict, having been told that one of four things actually came of it. And they all said, I would have seen that coming, even when told explicitly to try and avoid hindsight bias and told about bias. Illusory correlation. If you show people the raw data, people will come away with an impression that it confirms their prejudices about which things correlate with other things, even when the data has been cooked to bring about zero correlation or even a slight negative correlation. People come away reading the evidence thinking, yes, this backs up my prejudices. The overconfidence effect. What people say